Hello, this is Brooke Cologne for homework EL6 for homework 3 of EL6303. So we're going to be doing problem 1. And so it asks you to let P of x equal K be equal to, let me just write this out, P of x equals K equal to B times K, P, K minus 1, when K is equal to 1 all the way to infinity, and P is between 0 and 1, and so they asked us to find all these different conditions, find B, to E of x, the expected value of the, and then a lot of all the other things. So before we go through all that, there is a problem that's pretty similar to this one that we're looking at, that's going to basically help us with trying to find all these other answers. So let's just run through that really quickly, and this is how we're going to get our answers. So we're going to consider a summation of probabilities. So basically we're kind of considering only P to the K, and then these other values will find their way in. So we have sum of, from when K is 0 to infinity, of P of K, which is equal to 1 plus P squared, and so on and so forth, which comes out to be 1 minus P. And then if we differentiate both sides with respect to P, we will get this sum of K to infinity, K, P, K minus 1. So already we're at K, P, K minus 1. So we're already semi-getting there, which is equal to 1 over 1 minus P squared, and then which is equal to sum of K equals 0 to infinity of K, P to the K equals P over 1 minus P squared. And again, we differentiate this to get 0 K squared P K minus 1 equal to, and I'm just going to write out the summation. Well, actually, I'll just write all of it out. We're going to just make it to link to shorten this. So sum of K equals 1 to infinity, K squared. We essentially did the same thing we did up here. P K equals to P plus P squared, 1 minus P to the third. And we differentiate one more time to get sum of K equals 0. Sorry. Oh man, sorry about that. I kept writing 0. Replace all these with, replace this one with 1. So, sorry, that's what I meant to do. I don't know why I put 0. So 1. There we go. To infinity. And we get K to 3, P, K minus 1 equal to 1 plus 4P plus P squared over 1 minus P to the fourth. which we can then say that the sum of k equals 1 infinity equals 1 to infinity of k p k minus 1 is equal to 1 over 1 minus p squared. Sorry. And then further saying that sum of k equals 1 to infinity of b times k p k minus 1 is equal to 1. So that therefore we can say what p is. B, because this is a property saying that from 1 to infinity that all of these come out to 1. So from here, simple math, we say that b is equal to 1 minus p squared. And then from our differentiating, k equals 1 k squared p k minus 1 is equal to 1 plus p over 1 minus p to the third. We now have can get the expected value of x, which is sum from k equals 1 to infinity b times k squared p times k minus 1 is equal to 1 plus p over 1 minus p. And lastly, we get from k equals 1 to infinity of k to the third of p k minus 1, which we earlier said was this value, 1 plus 4p plus p squared over 1 minus p to the fourth. We now have the expected value of x squared, which is sum from k equals 1 to infinity b k to the third p k minus 1 equals 1 plus 4p plus p p squared over 1 minus p squared. So what does all this come out to? This all comes out to the answer to all of our problems, which is the first one. The first one is asking for what is b, so that p of x equals k represents the probability mass function. Well, we just did that up here, didn't we? That's what b equals, because we just said for all of this summed to equal 1, b must equal 1 minus p squared. See? Just bring this over, and that equals 1. So b equals 1 minus p squared. That's the first one. Second one asks for find e of x. Well, we did that earlier. We did that up here. It's 1 plus p over 1 minus p. C is asking for e of x squared. Again, you saw how we did that. It's up here. 1 plus 4p plus p squared over 1 minus p squared. So 1 plus 4p plus p squared over 1 minus p quantity squared. This fourth one, which is D, asks for e of x squared minus e squared of x. So that's pretty much math. And so let's see, it says e of x squared minus e, oopsie, excuse me, minus e squared of x. So again, this is just some math that so we have 1 plus 4p plus p squared over 1 minus p quantity squared minus square of 1 plus p over minus p literally squared. And so, excuse me, this is all just math. So this is literally just algebra, which you can figure out. I don't need to go into how you need to do this, but that's essentially the quantity we're given. And then the last one is asking for if we let p equal, say that p equals 1/3, to find the conditional probability mass function of p of x equals k, given that x is between 2 and 5 inclusive. So given that b is equal to 1 minus p quantity squared, we know that this is equal to 4/9. And so p, probability that x equals k, being equal to b bk pk minus 1, minus 1, given that k is equal to 1 all the way to infinity, and that p is equal to 1/3. Excuse, my shoulder is hurting right now, so it's a little difficult for me to take this video. We have probability that x equals k and is between 2, oh my goodness, it's between 2 and 5. Is between 2 and 5. Okay, I'm just gonna talk the rest of this out because I can't hold this and do this at the same time. So we have the probability that x equals k, and that it's between 2 and 5, over the probability that x equals k, the sum of that when x is 2 all the way through 5. And then, of course, you just plug in the numbers, and you have probability that x equals k over 2 through 5, and 2 through 5, over the summation that x is equal, the summation from 2 through 5 of 4 divided by 9 times k times p, which is 1/3, raised to k minus 1. And then this comes out to, this I can write down, 1 over 0.54 times 4 over 9 times k 1/3 to k minus 1. This part I couldn't write out as that my shoulder is giving me issues.